Welcome back to another exciting chemistry lesson. In this video, we are going to look at limiting reactant. And how do we find it? First, limiting reactants are basically the reactant that consume first. Now, in a chemical reaction, like in this case, you have two reactants. How you know which one is going to be consuming first? Well, in order to do that, you have to look at your given values. And then before we do that, we have to first make sure that our chemical reaction is balanced, okay? And then we are going to convert all the reactant, whatever values given to you, and convert them all into mole. Now, once you do that, then you have to choose one of the reactant or the product that you would like to convert them all into. So it has to be the same reactant or product. And the smallest one or the smaller one will be your limiting reactant, and the other reactant will be your excess. So let's do one problem. In this case, you have this chemical equation here is already balanced already, okay? So that's the key, is balanced already. Now, we are given 30 milliliter and molarity of that particular reactant right here, and the mass in decimal of Fe right there. So we get that information done. Now, the extra step is just there to trick you, but sometimes it's important. In this case, this is solution. We don't really care about the temperature and the pressure. That's only when you have a reactant give you in terms of gaseous form. So here, this is where it gets really tricky because you're not allowed to use calculator in this case. So what we have here is, let me label this out, HCl, okay? So we have 30 milliliter. Well, first of all, you need to convert that to liter by dividing by 1,000. Okay, so basically move decimal 1, 2, 3. See, 1, 2, 3. So I have 0.030 liter. And once I have that, I multiply by the molarity. Okay, you see right there? Molarity is basically, by definition of molarity, we have moles. So here is your molarity right here, 1.0 m of HCl. That's written as a conversion factor. Notice how liter cancel out. So in this case, multiply by 1. So 0.03 mole of HCl. So we have our mole right there. See that right there? Convert to mole. Now the next thing we have is our Fe. Well, we are given 0.56 grams of Fe. And the molar mass of Fe is what? Well, the molar mass of Fe is 1 mole of Fe equal to 55.85 grams of Fe. Now, we're not allowed to use calculator, so we had to estimate this is around to be about 56, okay? So I'm going to put 56 grams of Fe. Notice how gram and gram cancel out. 1 mole of Fe, there you go. So gram cancel out. Well, what we have left is, of course, moles of Fe. But before we do anything, I want to show you the math behind this. See what's 0.56? That is the same thing as 56 times 10 to the negative 2, because I moved this decimal over here. The goal is so that we can make the number easy to divide. So what we have here is 56 times 10 to the negative 2 divided by 56, okay? I didn't write out the word mole of Fe because we already kind of know it there. Notice how 56 cancel out with 56 right here. So basically 1, right, times 10 to the negative 2 moles of Fe. Well, we don't want to deal with this number. It's too complicated, so we convert back to decimal. So here's negative 2. We bring back 1, 2. So 0.01 moles of Fe. Now, the next step we have to do is we want to make sure they are the same chemical because we have HCl and Fe. So in this case, I want to choose, and I'm going to convert HCl to Fe. So I'm going to do this. I'm going to multiply it by the mole ratio from the balanced chemical equation. Here's we have 1 to 2 ratio. Basically, 1 moles of Fe equal to 2 moles of HCl. So here I have 2 moles of HCl, 1 moles of Fe. See where I get this from? From the balanced chemical equation. And that cancel out. Well, what is 0.03 divided by 2? So that is equal to 0.015, right? And that gives us moles of Fe. Now we have Fe and Fe. Which one's smaller? This one is smaller. So therefore, that one is your limiting reactant, and this one's your excess. And that is all we have to do. So be careful with the math part, okay?